This is going to blow your mind. The universe is a vast and intricate tapestry of celestial bodies, swirling nebulas, and mysterious forces. It's a cosmic dance, a never-ending ballet of creation and destruction that has captivated humankind since the dawn of time. But what drives this intricate dance? Is it a pre-programmed sequence, a cosmic algorithm dictating every twirl and leap, or is it something altogether more profound? For centuries, we've sought to decipher the universe's secrets, to unravel the laws that govern its every move. But what if the universe isn't some giant clockwork mechanism ticking away with predictable precision? What if it's a self-organizing system, a symphony of emergent complexity? We humans have a penchant for patterns. We see faces in clouds, meaning in randomness, and order in chaos. And so it's no surprise that when we gaze up at the vast expanse of the cosmos, we see laws governing its every motion. We talk about the laws of gravity, the laws of motion, the laws of thermodynamics, but what if these so-called laws are nothing more than human constructs, convenient simplifications that allow us to make sense of a universe far more complex than we can possibly imagine? They are descriptive, not prescriptive. They tell us what happens, but not why it happens. The universe is not bound by our equations, nor is it obligated to conform to our expectations. It simply is. But if the universe isn't governed by predefined laws, then what drives its intricate dance? One intriguing possibility is that the universe is, at its core, computational. This is the central thesis of Stephen Wolfram, who argues that the universe is a vast network of interconnected nodes, each one processing information and interacting with its neighbors according to simple rules. From the intricate dance of DNA molecules to the complex neural networks firing in our brains, computation is the language of life itself. This computational view of the universe challenges our traditional notions of space, time, and causality. It suggests that the universe is a self-organizing system constantly evolving and adapting through the interplay of countless individual agents. Our human minds, for all their remarkable capabilities, are fundamentally limited. We think in linear terms, our thoughts constrained by the rigid structures of language and logic. We crave certainty, predictability, and clear-cut answers. But the universe, it seems, dances to a different tune. Our algorithms work wonders within the confines of our computers, but often fall short when confronted with the messy, unpredictable reality of the natural world. Take, for example, the weather. Despite sophisticated models, we can only predict it accurately a few days out. This is not to say that algorithms are useless. They are essential tools for understanding and navigating our increasingly complex world, but we must recognize their limitations and embrace the non-linear emergent nature of the universe. Stephen Wolfram offers a radical proposition. What if the universe isn't governed by laws but by computation? What if reality is a vast interconnected network of simple programs? In Wolfram's computational cosmos, there are no fundamental constituents of matter, no grand unified theories, no elegant equations etched into the fabric of space-time. There's only computation, an endless dance of information, processing and transformation. Central to Wolfram's theory is the concept of cellular automata, simple computational models that can generate incredibly complex and unpredictable patterns. While Wolfram's ideas remain controversial, they offer a glimpse into a universe where complexity emerges from the bottom up. To understand the universe as a computational system, we need a new language, a language that can capture the intricate web of relationships and interactions that define complex systems. That language, Wolfram argues, is the language of graphs. A graph is a collection of dots, nodes, connected by lines, edges. These simple structures can represent an astonishing array of real-world phenomena, from social networks to neural pathways. In Wolfram's computational cosmos, graphs provide a powerful way to visualize and understand the interconnected nature of reality. These are the realms of random graph theory, where order emerges from the sheer complexity of the underlying network of interactions. Randomness, at first glance, seems the antithesis of order, yet delve deeper and we find that randomness is not the absence of order, but rather the breeding ground from which complexity can emerge. Imagine a vast cosmic web, a network of countless interconnected points, each representing a fundamental element of the universe. As more connections are made, patterns emerge, clusters form, and hubs of interconnectedness appear. This is the essence of random graph theory, where order emerges not from design, but from the very nature of interconnectedness itself. Emergence, that elusive concept that dances at the edge of our understanding, is the heart of this cosmic ballet. It's the idea that complexity can arise from simplicity, that order can spontaneously emerge from chaos. Think of a flock of birds, swirling and swooping in perfect unison. Each bird acts independently, yet a complex pattern emerges. This is emergence in action, a testament to the universe's remarkable ability to self-organize. In random graph theory, as the number of connections increases, a giant component emerges, analogous to the formation of galaxies. The emergence of social networks, the spread of ideas, and even the evolution of life itself can be seen as manifestations of this same fundamental principle. But if the universe is indeed a self-organizing emergent system, does that mean there's no underlying algorithm, no code that governs its behavior? Not necessarily. While the universe may not be governed by a pre-written algorithm, there's undoubtedly an underlying logic. Think of the rules of chess. Simple rules give rise to a game of astonishing complexity. Similarly, the universe's algorithm may be relatively simple, but the vastness of the cosmic playground allows for an unfathomable level of complexity to emerge. This unwritten algorithm is a dynamic, ever-evolving set of principles that manifests in the emergent properties of the universe itself. Understanding this unwritten algorithm is the ultimate challenge for science, a journey into the heart of complexity itself. Look around you. The world is awash in complexity, a riot of patterns and structures that seem to defy explanation. From the intricate branching of a tree to the swirling chaos of a hurricane, nature revels in its ability to create order from what appears at first glance to be randomness. Consider the humble snowflake, each one a unique masterpiece, a testament to the intricate dance of water molecules as they crystallize around a dust particle in the cold upper atmosphere. There's no grand plan, no blueprint guiding their formation, just the simple laws of physics and a touch of chaotic air currents. Yet, from this apparent randomness emerges an astonishing degree of order. Each snowflake, a six-sided wonder, exhibits a mesmerizing symmetry, a testament to the underlying order that governs the behavior of water molecules at the atomic level. This interplay of randomness and order is a recurring theme in nature, a kind of cosmic Rorschach test, inviting us to find patterns and meaning in the seemingly chaotic canvas of the universe. The human brain, hardwired to seek out patterns, readily accepts the challenge. We see faces in clouds, animals in star constellations, and divine messages in the arrangements of tea leaves. This innate desire to find order in randomness is both a blessing and a curse, a source of both profound insight and dangerous delusion. Order, it turns out, is not always imposed from above. It can also emerge spontaneously, a symphony of synchronization arising from the interactions of countless individual agents, each acting according to its own simple set of rules. Consider the firefly. A tiny creature flickering in the darkness, its luminescence a beacon to potential mates. Each firefly flashes independently, its internal clock dictating the rhythm of its light show. Yet as darkness descends and the fireflies gather, something magical happens. Their individual flashes begin to synchronize, their tiny lights merging into a mesmerizing, coordinated display. There's no leader, no external signal coordinating their movements, just the simple act of each firefly adjusting its internal clock in response to the flashes of its neighbors. This phenomenon, known as spontaneous synchronization, is a testament to the power of emergence, the ability of simple interactions to give rise to complex, coordinated behavior. It's a phenomenon that's not limited to fireflies either. From the beating of our hearts to the rhythmic firing of neurons in our brains, Synchronization is the invisible hand that orchestrates the symphony of life. It's the driving force behind the flocking of birds, the schooling of fish, and the collective intelligence of ant colonies. The universe is like a river, constantly flowing and ever-changing. It doesn't follow a predetermined course, but responds to the landscape, gravity, and weather. Over time, it carves its path, adapting to new obstacles. The universe, like a river, is a dynamic, self-organizing system. Change is the only constant, always exploring new possibilities. Within this grand, flowing river of reality, it's easy to feel insignificant. But what if we're not just passive passengers on this cosmic journey? What if each of us plays a role in shaping the flow of reality? Imagine every atom, every particle, as an agent with unique properties. These agents constantly interact, forming bonds and breaking free. Through these interactions, the grand patterns of the universe emerge. A galaxy spirals into existence, not from a blueprint, but from stars coalescing. Life arises from molecules self-organizing, driven by evolution. We too are part of this grand, emergent dance. Every thought and action sends ripples through reality. We are agents of change, active participants in the universe's story. But where did this grand cosmic dance begin? What was the stage upon which this epic drama of creation and destruction first unfolded? The answer, as paradoxical as it may seem, lies in the concept of nothingness, the void, the empty set. In mathematics, the empty set is a fundamental concept, a set with no elements. It's the ultimate blank slate, the starting point from which all other sets can be built. It's the mathematical equivalent of nothingness. Yet within this nothingness lies boundless potential. For if there were truly nothing, then there would be no possibility of something. It's from the void, the empty set, that the universe, in all its mind-boggling complexity, could emerge. Imagine, if you will, a state of pure potentiality, a realm of infinite possibilities, unconstrained by the laws of physics as we know them. It's within this realm, this cosmic womb, that the seeds of our universe were sown. Perhaps it was a quantum fluctuation, a random blip in the fabric of space-time that shattered the silence of the void. Or maybe it was something altogether more profound, something beyond our current understanding of reality. Whatever the cause, the result was the same. The birth of our universe, a universe bursting forth from the void, a universe pregnant with possibility, a universe destined to become the cradle of stars, galaxies, and life itself. For centuries, we've sought to understand the universe by breaking it down into its smallest parts, reducing it to its fundamental building blocks. We've sought the ultimate particles, the fundamental forces, and while this approach has yielded incredible insights, it's also led us to a somewhat sterile view of reality. To truly grasp the wonder of the universe, we need to move beyond the building blocks, embrace the emergent complexity that arises from their interactions. See the universe not as a giant machine, but as a living, breathing organism, a self-organizing, self-creating entity of unimaginable beauty and complexity. The idea of a universe without laws, a universe governed not by rigid equations, but by the elegant chaos of emergence, can be both exhilarating and unsettling. It challenges our deeply ingrained notions of cause and effect, of order and predictability, of a universe that, despite its vastness, ultimately plays by a fixed set of rules. If there are no fundamental laws, no cosmic instruction manual guiding the evolution of the cosmos, then what are we left with? Chaos? Randomness? Meaninglessness? Not at all. For in the absence of preordained laws, we find something far more profound: freedom. The freedom for the universe to create itself, to explore an infinite landscape of possibilities, to evolve and adapt in ways we can scarcely imagine. This is not to say that the universe is arbitrary or capricious. The patterns we observe, the structures that emerge, are not mere accidents. They are the products of billions upon billions of interactions, each one shaped by the underlying principles of emergence and self-organization. The universe, in a sense, is constantly making itself up as it goes along, improvising, experimenting, exploring the vast potential hidden within the void. And we, as products of this grand cosmic dance, are privileged to witness and participate in this ongoing act of creation. So, the next time you gaze up at the night sky, remember this: the universe owes you no explanation, it simply is. The dance of creation and destruction, the ebb and flow of energy and matter, this is the music of the cosmos, a symphony billions of years in the making. And we, for a brief moment, are privileged to hear its song. Let us dance along, marveling at its beauty, humbled by its grandeur.